Let's explore a fundamental concept in 5G new radio that significantly enhances performance across various use cases in 5G. And that concept is a flexible subcarrier spacing, or what we call numerologies. Now, there are different numerologies in 5G. It could be ranging from 0 to 4, which is corresponding to the subcarrier spacing of 15 kilohertz to 240 kilohertz. Now, these are applied depending upon the deployment scenario. For example, the 15 kilohertz subcarrier spacing is commonly used for wide area coverage, whereas the subcarrier spacing of 3 or 4 is ideal for high throughput, which is referring to 120 or 240 kilohertz, which is used for low latency applications. Now, this flexibility enables certain new use cases such as network slicing and support diverse performance requirement. Now, with the flexible subcarrier spacing, what we can achieve while designing a network, we can achieve better coverage. Lower subcarrier spacing, we talked about 15 kilohertz, which results in longer symbol durations. This makes the system more tolerant to delay spread and Doppler effects, which are prominent in larger cells or low frequency deployments. So if you are designing a network for rural or suburban areas with wider cells, using a lower numerology improves signal overall coverage. It also helps to get a better latency depending upon the subcarrier spacing we are choosing. So higher subcarrier spacing like 60, 120 or even 240 kilohertz reduces the symbol duration. And this directly translates into low transmission time interval (TTI) and hence reduced latency. This is critical for applications like vehicle to everything communication and time sensitive industrial automation. And if we see overall, the numerologies allow 5G to adapt to different deployment environments, and hence designing these numerologies are very important. Let's understand it with an example. We know there is a fundamental trade-off when selecting the subcarrier spacing. So if we have the lower subcarrier spacing, we have a better coverage, we have a larger cell size. Here we are taking an example of 15 kilohertz. But here the latency is high, that's what we can see in this table. If we look at another option where we are going for the higher subcarrier spacing, say for example 60 or 120 kilohertz, in that case, the latency is low. It means there is a faster data transmission. It is perfect for ultra reliable low latency use cases. But here the cell size is smaller. It has a limited coverage. So if your goal is broad coverage, go for 15 or 13 kilohertz. If you are aiming for low latency, in that case, go for the higher numerology. So when planning and deploying a 5G network, choosing the right subcarrier spacing is very critical. It affects your latency performance, signal reach, spectrum efficiency, and the type of services you would like to provide.